Hi, I'm Mira. In this video, I'll be demonstrating about voltage divider simulation using Tinkercad. This project demonstrates how a light sensor interacts with a motor and LED to respond to changes in light intensity. The circuit uses an Arduino Uno R3 photoresistor, DC motor, voltmeter, potentiometer, LED. Two resistors consist of 150 ohm and 10 kilo ohm. I also use photoresistor, also known as light sensor, breadboard, and different color of wires. Before we begin, here's a quick overview of the main components used in this project. Arduino Uno R3, which is the microcontroller that processes the sensor input and output that control the motor and LED. 9-volt battery powers the motor and the Arduino Uno R3. DC motor converts the electrical energy into mechanical energy. LED and 150 ohm resistor. As for the LED provides visual feedback and the 150 kilo ohm limits the current to prevent the damage. Photoresistor and 10 ohm resistor form a voltage divider to measure light intensity. As for the potentiometer, it is used to adjust the reference voltage for fine-tuning sensor readings. Voltmeter monitors the output voltage across specific components. Now, let me walk you through the connections and explain why each one is important. 9-volt positive terminal connects to the DC motor, and Arduino Uno GND's terminal. The motor's second terminal connects to digital PWM pin 9 on the Arduino Uno to allow speed control via pulse width modulation PWM. For the LED, the cathode, which is the negative leg of the LED, connects to GND on the Arduino Uno, while the anode, which is the positive leg, connects to PWM pin 9 via 150 ohm resistor. Why the 150 ohm resistor? The resistor limits the current flowing through the LED to prevent from burning out. Without it, the LED would draw too much current, potentially damaging itself and the Arduino Uno pin. The photoresistor and the 10 kilo ohm resistor form a voltage divider. One end of the photoresistor connects to 5-volt terminal on the Arduino Uno, while the other connects to the 10 kilo ohm resistor and analog pin A0. Why this setup? Because this arrangement allows us to measure the changes in light intensity. When the light increases, the photoresistance resistance decreases, changing the voltage at A0. The 10 kilo-ohm resistor ensures a consistent reference point for the voltage divider. Now, what about the potentiometer? Well, the first terminal connects to 5-volt pin on the Arduino Uno R3. The second terminal, which is the middle one, connect to analog pin A1, and the third to G and D. Why we use potentiometer? Because potentiometer allows us to adjust the voltage reference to fine-tune the sensitivity of the light sensor circuit. What about the voltmeter? Or we also call it as multimeter. The voltmeter's negative terminal connects to G and D, and the positive terminal connects to a specific point on the breadboard to monitor voltage changes. Now, let me run the simulation and show you how it works. Observe the LED brightness changing with varying light levels. Watch the motor speed adjust as light intensity increases and decreases. Now, let's have a look at the code for this voltage divider simulation. Here's the code. Here's the schematic diagram for this simulation. And here's the list of components used in this simulation. If we have a look at this simulation at the bigger picture, by combining the photoresistor, potentiometer, and the voltage divider, we've created a circuit that responds to both light and manual control. This project showcases how simple components like resistors and sensors can create dynamic and interactive systems.